time to find the area between two curves. We are going to find the area between the functions f of x equals x squared plus x and g of x equals x plus 1 on the interval -1 to 2. I think this is a good practice problem to practice integrating polynomials and also thinking about how area relates to integrals. First off, we have to figure out which subintervals have this function higher and this function higher, because we need to integrate, find the area between the two curves on each chunk where one function is higher. I'll check first where the two functions cross. That means I need to set them equal to each other. Oops, my equal sign came out in the wrong place. And now this is a quadratic. To solve a quadratic, remember we get all the terms over on one side. I do that by subtracting x and 1 from both sides. This is the difference of two perfect squares, you may remember. You could also just think about it as factoring, so x minus 1, x plus 1 equals 0. Now this is 0 when x equals 1. This is 0 when x equals -1, so this equation is true when the functions are equal. So the functions are equal at x equals -1 and x equals 1. That means my subintervals are -1 to 1. I'm guaranteed that one of the functions is higher between those because these are the only two places that they cross, and the rest of my interval is 1 to 2. Now I have to figure out which function is higher actually on the interval -1 to 1. I'm guaranteed that one is higher or the other one. Let's check a point in the middle. How about we check f of 0, which is 0 plus 0. I like that. And g of 0 is 0 plus 1. So I'm pretty sure that g of x is larger than f of x. That means I get to do the following integral to find the area. I'm integrating from -1 to 1, that's my interval, and I'm going to start with g of x, that's x plus 1. I'm going to subtract f of x. That will get me the area on that subinterval. Now, first off, I think I'd like to simplify the expression inside. We call it the integrand. Here's how we'll simplify it. I'll cancel the x's. I have a positive x and a minus x. So really I end up with 1 minus x squared dx. And I actually know how to integrate that pretty efficiently. First off, I'm going to integrate the whole thing from -1 to 1, remember. So integrating 1, you could think of that as x to the 0. The power goes up by 1, so that's x. You could double check the derivative of x is 1. Integrating negative x squared, to integrate the negative, I'll have to have something that's negative. X squared, I need to raise the power by 1 to integrate, so x to the third. Now if you took the derivative of x to the third, you'd get 3x squared. And so you remember our rule is that we put a 1/3 out in front. Oh, but not there. How about there? So 1/3 x cubed is the integral of x squared. Now we need to evaluate that whole thing. How do we evaluate it? Well, I'm going to plug in 1, so I have 1 minus 1/3 times 1 to the third. Oops. Let's see if I can't put a space so that it separates it rightly. So that's the first piece. Then I'll subtract evaluating the whole thing at -1. So I have -1 minus 1/3 negative 1 to the third. Let's see, and in this first piece, that comes out to just 1 minus 1/3, so that's 2/3. In the second piece, let's see, what is that going to be? Negative 1 to the third, that's an odd number of negatives, so this will give me a negative sign, but the whole thing is subtracted, so now that's a positive 1/3. So I have negative 1 plus 1/3, that gives me negative 2/3. So now I have negative 2/3 that I'm subtracting, so that's going to be actually positive 2/3, and I end up with 4/3 total. Okay, so the area between the two curves on the interval negative 1 to 1 is 4/3. Let's look at that picture and see if we can't interpret that. So, Wolfram alpha again. Let's look at the curves x squared plus x and x plus 1. Okay, so I have the area between the curves. Notice they cross at negative 1 and 1. That part of my calculation was good. And notice that the x plus 1 is higher. Now the area between those two curves, that comes out to 4/3. That seems about reasonable. I also need to find the area between 1 and 2. And here the x squared function is going to be higher. So I'm halfway done with my integration. Now I'm going to go back and work on the other integral. So on my other subinterval, that is from 1 to 2, I'm going to be taking the function x squared plus x minus the function x plus 1. I can simplify that again. And that comes out to x squared minus 1. Now, when we're integrating, we've already done that, so let's do it fairly quickly here. It comes out to 1/3 x cubed for the integral of x squared. For the integral of negative 1, that's negative x, and we're going to evaluate that from 1 to 2. Okay. And I'd like to go ahead and numerically plug in 2 to start with. If I have 1/3 times 2 to the third, that is 1/3 times 8 minus 2. Let's go ahead and put that whole thing in parentheses just to remind ourselves that that's our first term. Then I'm going to subtract this function evaluated at 1. So I have 1/3 times 1 to the third, so that's just 1/3 minus 1. Now you might say, okay, 8/3, 8 times 1/3 is 8/3 minus 2. How could I think through that? You could think about that as 8/3 minus how many thirds is 2? Well, 2 is 6/3. And then in the second piece we have 1/3 minus 1. That's negative 2/3. So 8/3 minus 6/3, that is 2/3. And here we have minus negative 2/3, so that's 2/3 again. Hey, that's 4/3 all over again. So notice that the first integral is 4/3, the second integral is 4/3, so we conclude that the area between the two curves on the interval negative 1 to 2 is 4/3 plus 4/3, which is 8/3. And that's it.